Okay, let's go for one more video today before I cark it. So I've just gone through and I've showed you all these reflection matrices and where they came from. So now we're going to apply them. So I've already shown you that there's the equation that we've got. So the transformation is going to happen when we go. We don't want that colour. The transformation is going to happen. We're going to get an image, and how we're going to get that? We're going to have whatever our transformation matrix is times by our x, y. Okay. So in this particular example, we are going to have a reflection in the x-axis. So our image x1, y1 is going to be found by multiplying the matrix. And I'm just reading that straight off the formula sheet. The matrix is a reflection in the x-axis multiplied by whatever's being transformed and getting the resultant. In this case, it's -2, 3, -3. Okay, straightforward. That's A. And then B is after it's transformed by the matrix. Okay, so we've now got still that original point, and we've got a new matrix. So again, we're going to go x1, y1, x dash, y dash. What am I saying? No. So x dash, y dash is equal to the given transformation matrix multiplied by the point that is being transformed, and we're going to get negative on negative positive, and positive is there, and in this case that was a reflection in the y-axis because that was this rule here. Okay, let's keep going. So now I want to determine the equation of, so I'm now going to have a quadratic being moved. So I'm going to have its reflection. So the same deal, we're going to have to set it up. So same as those ones I did earlier, we are now just going to have to find out what y does and what x does in terms of the image. Okay, and so I've got the reflection of the y-axis, that's just straight off the rule sheet. I'm going to reflect x, I'm going to reflect y. Okay, so first of all, I'm going to get my image. My image there is going to be negative x, and it's going to be y. Okay, so my image is the same as negative x, which changes around to be x equals negative of my image, and image of my y is there, and that's obviously y equals x dash. Okay, so from my original equation, I had y equals x plus 1 squared. For my image, y dash is the same as y, so I can substitute it in. Negative x dash is the same as x. Okay, therefore my reflection, or my image, equation is going to be y equals 1 take x all squared. Okay, alright, let's keep scrolling through. Determine the coordinates of the point after reflection of the line y equals x. Okay, so again, we're just going to have our x dash, y dash. We need to know what is being multiplied by. That was the swap around. Okay, again, I'll just read that straight off the table. X, y. Okay, so go through and substitute my values in. 3 and 1, and get my right, it's slower. Sorry, going too fast. Therefore, my reflection equation, the coordinates of the image are going to be 1, 3. What else we got? Okay, determine the equation of the image after the reflection line y equals x. So first of all, we need to know our reflection matrix. So we're going to have to go our new image, or our image, it's not a new image. New image is equal to the y equals -1, -1, 0. Okay, for my x and y. Go through and solve it. So I'm going to get, this is going to be -y, and this will be -x. Okay, therefore, x dash is mirrored into -y. Therefore, y is equal to -x dash. And I'm going to get y dash is mirrored by -x, which means I'm going to get x is equal to -y dash. Now I'm going to substitute those into my original equation. So my original equation is y equals x squared. I'm now going to have, for my y, I'm going to have -x dash. For my x, I'm going to have -y dash squared. Okay, so that becomes -x dash equals y squared. Let's change that around. No, I'm going to leave it like that. Y dash squared. So what's happened there is you've got a quadratic equation here, and the quadratic is just straight, like this. Okay, and then we've got the reflection line somewhere there, and I've got reflection in that line. So my reflection for this particular graph is going to be something like, that's not drawn very well. The origin should have been where the thing turned. So the reflection of that is going to be that, which is so this is y equals x squared, and this is a y squared equals x graph. You can check in the calculator, you can check using y equals plus or minus root x, and it will draw it as 2 halves. The reason it's backwards is because it's actually a -y. Okay, so when I take this to the other side, so this will become -y squared equals x is my image equation. What am I calling it? Yeah, the equation image. So my image equation is -y squared is equal to x. Again, check it on your calculator. But the reason it's negative is because it's going the direction that I told you. And so similar to what quadratics do. So quadratics go happy, sad, okay, and reflections are positive and negative, and this one is positive and negative. Okay. Okay, the last one, the harder one. So let's have a look at this. So this is where we're now going to start using all the trigonometry, etc. Depending on what days you're given, whether it's a calc or a non-calc type thing. So let's have a play. So first of all, we know that y equals tan theta x. Okay, therefore we know a relationship between our gradient and our tan theta. So therefore, root 3 is equal to tan theta, and I can change that around using my triangles. Okay, so so my theta there is going to be, what was I doing? So I was doing 1 root 3, 2, opposite or adjacent. They were, sorry, but COVID did. Pi 1, 3. So my theta will be opposite over adjacent to get root 3, so it's going to be pi on 3. So theta is equal to pi on 3. Okay, so next we would need to create that as our matrix, and it's 2 thetas by the rule, nothing else. So I've got t is x1, y1. I'm doing exactly the same approach, it's just going to be yucky numbers. and I think you'll find there's more to this one. But anyway, so I've got cos of 2 pi on 3, and I've got sine 2 pi on, I wrote it 2 theta first, cos 2 theta, sine 2 theta, and because of the fourth quadrant, cos 2 theta is negative, and I'm going to times it by my x and my y. Hopefully I'm going to, I can add space. Okay, so this is going to be the same as cos double the theta, so cos pi on 2 pi on, I already said double it, cos 2 pi on 3, sine 2 pi on 3, sine 2 pi on 3, negative cos 2 pi on 3, x and y. Okay, so get those as values. Using the exact triangles across the top there is going to be cos 2 pi on 3 because of quad. So I'm going to do go slow. Cos 2 pi on 3 or 2 pi on 3 is in the second quadrant. Okay, so in the second quadrant, cos is going to be negative, and cos is going to be of it's going to be the same as negative pi on 6, which is going to be the same as negative a half. In sine, for sine there, I've got sine of 2 pi on 3, again second quadrant, which is going to be the same as sine pi on 3, which is going to be the same as root 3 on 2. Okay, and that's fine, and then that's same as sine root 3 on 2. So the next one is I've got negative cos 2 pi on 3, and I know that the cos 2 pi on 3 is already negative a half, so my negative a half becomes positive a half. I know that was pretty quick, but the video is getting long. Okay, so expand all that out, and I will get x dash equals, and I'll get negative a half x plus root 3 on 2y, and I get y dash is equal to root 3 on 2x plus 1 on 2y, and I've got two equations. I obviously have to solve them now for x's and y's, because I've got to get I've got to sub into the original equation, which was y equals negative x take 1. So I need to get y in terms of x and y dashes and etc. So equation 1 and 2, I've got to get so I'm going to get something for y and then something for x. Okay, so let's have a look at y. To eliminate y, I would need to get them the same. I've got one is root 3 on 2, and I got the other is 1 on 2, so I've got times them both by root 3 to eliminate the y. So let's have a look at that. What did I say? So I'm eliminating y. Let's take your time. So to get x, I'm going to go equation 1 minus root 3 times by equation 2. So I'm going to get x1 equals negative a half x plus root 3 on 2y. To get the same y value, I times all of this by root 3. So root 3 y dash minus root 3 on 2x. Yeah, that's right. Plus, no, it's going to be the whole number 3. 3 on 2x, and then my y becomes root 3 on 2y. I need some more space. So then I need to get in terms of y equals, I need to change that somewhere around. No, I'm not. I'm doing this. Sorry, I'm getting very code drained. So I'm going to get x1 minus root 3 y1. And because I'm minusing a whole lot, I'm going to get negative a half minus minus root 3 on 2 becomes plus root 3 on 2, this becomes whole number 2. Negative 3 minus, did I make an error somewhere there? Yes, I did. It didn't have to become minus, it was positive. So, negative a half minus root 3 on 2 will just become negative 2x, and I've eliminated that. So in terms of x by itself, therefore I'm going to get x equals a half x1 minus root 3 on 2y1. Okay, so now the x part. Now I'm just going to find the y part. So solving for y, again, let's have a look at what we got. Solving for y, I need to eliminate my x value. So the first equation times by root 3 will give me root 3 on 2, plus the second equation this time, because one's positive, one's negative. So I'm going to get root 3x1 equals negative root 3 on 2x plus whole number 3 on 2y minus, no, I said plus, just that whole equation. y1 equals root 3 on 2x plus a half on y all over. Okay, so I'm going to get root 3x1 plus y dash equals, eliminate the x, 3 plus a half is 2, so 2y. I need in terms of y, so take it to the other side. So take to the side, so y is equal to root 3 on 2x1 plus a half y1. Okay. So now they can be substituted up in that original equation, and hopefully I am done. So let's have a look. Therefore, original was y equals negative x. Take 1. I'm going to change my y to be root 3 on 2x1 plus a half y1. And I'm going to change my x to being half x1 minus root 3 on 2y1 minus 1. Now I'm going to get all my x's together and all my y's together. Okay, and then hopefully it is all over a drover. So, collecting all my like terms. I'm going to put y's on one side and I'll put the x's on the other side. That's what I'm going to do. So I'm going to leave this half y here. I'm going to go plus or double. Okay, this negative and this negative. This means it's a plus. So when it comes to the other side, it'll be a negative. So negative root 3 on 2y dash dash equals. I'm going to take this becomes a negative a half x1. And I had to turn the other one to the other side, so minus root 2 on 3x1 and minus 1. Bring all that together, common denominator. So I've got 1 take root 3 onto y1, which obviously has to go to the other side at some stage. And I'm going to have 1 take root 3. Yep. So 1 take root 3, and then 1 take root 3 y dash, and I've got negative 1 minus root 3 on 2x1 take 1. I'm going to times everything by 2, get rid of that 2. So I'm going to get 1 take root 3 y1. I should have done a whole video just for this one. And negative 1 plus root 3 x1 take 2. Divide everything through by that. So I get negative 1 plus root 3 over 1 take root 3 x1 minus 2 over 1 take root 3, and that's the end. Okay, I might have to redo that as another video. Anyway, that'll get you started.